So hello, let's begin from the previous video only, where we talked about the basics, very basics of this alternating current. Now, as I explained the various terms, here is this term phase constant, you can say. It's not necessary that the moment you saw the current flow, it was happening from t equal to 0 only. For example, the moment you saw the cycle of the current, it can happen that the current was indeed here and it went like that and again and this continued. Yes, so you can see that at t equal to 0, current is neither having the maximum value nor the minimum value. Like I is equal to I naught sine omega t plus phi, if I say this is the function. So at t equal to 0, I is equal to I naught sine omega into 0 plus phi. So it gives me I naught sine phi. Yes? Yes. So if that's the case, this means that this sine phi, this constant, this phi is deciding what would be the value of I at t equal to 0. यानी 0 टाइम पर I की क्या वैल्यू होगी, and it was I naught sine phi. So phase constant is this thing only, which decides what is the value of my vibrating quantity at t equal to 0. If at t equal to 0, I is equal to 0, then phi has to be 0 degree. You can see that I is equal to I naught sine omega t plus 0 अगर मैं करती हूँ तो मैं यहाँ पे अगर t की वैल्यूज पुट करती हूँ तो आई विल गेट I t equal to 0 as 0 ampere. Units are quite important in physics, so आपको units का ध्यान रखना है हमेशा. So this is the case. But and why it's happening? Because here at t equal to 0, the value of the current in the circuit is 0 only. So if I have to draw this I versus t graph for this type of case, it would be like this only. Current would start from t equal to 0 only. And now if the case would have been a little different, ये तो t equal to 0 का case है. If the case would have been such that if the case is such that at t equal to 0 seconds, I is equal to I naught. If this is the case, then what should be my phi? So if I write it this way, I is equal to I naught sine omega t plus phi, and let me calculate this phi for myself. So I at the place at t equal to 0, I equal to I naught, as I have written earlier also. So I'll put I naught at the place of I. So it's I naught sine omega t की जगह पे मैं omega into 0 लिखूँगी क्योंकि मैं t टाइम की सिचुएशन देख रही हूँ. तो I naught equal to sine phi, and this is I naught, then I naught divided by I naught equal to sine phi, which gives me sine phi equal to 1. So phi will be equal to 90 degree, yes? So this means that your equation would be I naught sine omega t plus 90 degree. Now if that's the case, what do you think? How would the equation change? It would be 90 plus theta is cos theta. So it would be I naught cos theta. The equation would be like that. And in that case, if you draw the graph, it would be like this. Okay, so this is how we all must know and understand the meaning behind various concepts. Yes? So this is your I versus t graph again. And you can always find the time period, the time in which the cycle completes itself. Yes, it's quite important. This factor, this omega, is very important when you will be applying alternating current to to a capacitor and an inductor. Okay, so let's do one thing now. Firstly, we need to know the average value. I'm sorry for this. Just a second. average value of AC. This is what we are going to study over a cycle. ऑल्टरनेटिंग करंट की वैल्यू एक कंप्लीट साइकिल पर कितनी होगी, ये हमें देखना है. तो इफ़ आई जस्ट आस्क यू टू जज इट बेस्ड ऑन योर अंडरस्टैंडिंग, व्हाट डू यू थिंक? दिस इज how the value increases, then decreases, then goes in opposite direction, and then further becomes zero. My cycle is this one, is still this one, this time only one cycle, and this is the maximum value it's reaching. This is the maximum value in opposite direction, and this is what is happening. So I need to get the average value. Yes, so if I first I know I is equal to dq by dt. Yes, so since this is a varying current, I dt will be equal to dq, and over a complete cycle, let me see how much charge passed through the circuit. So 0 to t, I'm just going to integrate the charge passing through the circuit, and we'll see what do we get. I dt. Yes, let's put the values of I here. It's I naught sine omega t dt. Now I naught is outside because it's a constant, it's the maximum value. Sine omega t will stay inside, and when you will integrate it out, sorry for this trouble that is occurring here. So if you see it this way, so sin omega t का जब आप इंटीग्रेशन करेंगे तो आपको क्या मिलेगा? It would be माइनस कॉज ओमेगा टी, एंड जब हम कॉज ओमेगा टी की वैल्यू 0 से t देखेंगे, जस्ट अ सेकेंड, आई साइन ओमेगा टी इज so if I'll put the values, I'll see minus cos omega t minus plus cos 0. What would it be? Minus cos omega t means cos 2 pi upon t into t, plus cos 0 means 1. I naught minus cos 2 pi is minus 1 plus 1, and this would give me 0. So I can see that Q for a complete cycle is 0 कूलम. एक पूरी कंप्लीट साइकिल पर Q की वैल्यू 0 कूलम आती है. यस, सो इफ दैट्स द केस, अगर नेट चार्ज फ्लोइंग अक्रॉस द सर्किट इज कमिंग आउट टू बी 0 फॉर वन कंप्लीट साइकिल, दिस मीन्स दैट द करंट फ्लो फॉर दिस कंप्लीट साइकिल विल ऑल्सो बी 0. यस, सो लेट्स राइट दैट. Cycle of AC is 0. This is a fact to be remembered, or I can say you have derived it also, so you can take note of it. It's important. I'm just getting a bit doubtful about this, the integration of cos sine function that we took. Yes, we have taken the right integration. Yes, the integration for sine is minus cos only. So this is one derivation, very the initial part. Why? Because it's quite important to know this. Why? Because when this way, if I will apply alternating current on any circuit, I would say that for one time period there was no current in the circuit, isn't it? This means it's giving me I average to be 0 ampere. So there was no current in the circuit. That's quite a unique situation. But ऐसा तो नहीं हो रहा कि circuit से current नहीं जा रहा है. So to make the life easier and to see how much AC is to be flown across a circuit, so that we can relate it to a DC circuit also, we calculate the square of it. Okay, so what I'm gonna do is I square. I'm gonna calculate. Why? Because when I'll take I square, the directional effect, the alternation which is happening in the direction will get nullified. Why? Because पॉजिटिव प्लस आई हो या माइनस आई हो, दोनों का स्क्वायर आई स्क्वायर ही होता है. यस, सो दैट्स वाई आई एम गोना टेक आई स्क्वायर. सो लेट्स फाइंड आउट द इंटीग्रेशन ऑफ आई स्क्वायर dt. And for that, what am I going to do? I'm gonna calculate the heat released in this circuit. H was given by I square RT, if we remember, if we know this. Yes, and if I have to calculate the small heat generated, let's say dH, small heat generated, I'll make it as I square R dt. And now I have to integrate it over one complete cycle, that is 0 to time period, and this is 0 to t again. So this is your heat generated across one cycle. What I'm doing is I'm applying an AC source to a resistor. This is my resistor, and I'm just calculating how much heat is generated across this resistor when an AC source is connected across R. If the same amount of, like if I would have connected a DC source across this resistor, which gives me a maximum value of I naught, it's going to give me a constant value. So if it's giving me a maximum value I naught, a constant current I naught, then heat generated would be I naught square RT. Yes, over one particular time period. I'm just gonna do this for this case because here the current is not I naught, current is I naught sine omega t. At varying time, the current is going to be different. So I'm going to calculate it over one complete cycle. So 0 से t time period हम लेंगे, and at the place of I square I will put I naught square sine square omega t r dt. Yes, now here I naught square is a constant, r is a constant because it's a resistor whose value is not going to change over a time period. The only factors that are left with me inside the integral is sine square omega t dt. Yes, now I'll just take it out. I naught square r. अब साइन स्क्वायर का इंटीग्रेशन करने के लिए आई एम गोना सब्स्टिट्यूट, एंड आई एम गोना यूज दिस आइडेंटिटी cos 2 omega t. So 1 minus cos 2 omega t and upon 2 would be here dt. Yes, because there is this identity called cos 2a is equal to 1 minus 2 sine square a. Yes, so I'm using this identity. Now I naught square can stay out, square r, and 2 can also be brought out, and I have these two terms in my integral. So let's do the integration. You can always write this omega t as omega t plus phi for any generalized case. Okay, so I'm trying to simplify it, that's why I'm not added phi here. Now I naught square r, integration of 1 would be t, and integration of cos 2 omega t will be minus sine omega t, minus sine 2 omega t upon 2 omega. Am I correct? For the previous case, what we did, we took the integration of sine as minus cos, so the integration of cos would be, integration of sine I took as minus cos. So integration of cos is plus sine, it's not minus, it's plus only. Yes, so now I'll put the values of the I'll put the limits here, and let's put them. So at the place of t, it's capital T minus, this is plus sign only, so it would be sine 2 omega capital T upon 2 omega. Then minus, at the place of t I'll put 0, then again the minus will become plus, it would give me sine 2 omega into 0 upon 2 omega, and this is how I have put the limits. Let's solve them. It would be I naught square r, it would be t is fine here, and see I've just left this 2 here, it's important, this 2 is going to bring the change, you will see. Now when I'll put the value here, sorry for this. Yes. When I'll put the values here, sine 2 omega. 2 omega means it's basically sine 2 pi upon t into t, and there's this 2 omega at the bottom, minus 0 plus sine 2 omega into 0 will be sine 0, which is 0. Yes. And then if you'll cancel out this t with t, you are left with sine 2 pi. This term is again 0. Yes. So what are we left with? We are left with H heat generated across this one cycle as I naught square R upon 2 capital T. In case of AC, I am getting this as the heat generated in one cycle, whereas in case of DC, I am getting I naught square RT as the complete heat generated. So if I have to relate this with this, what I would say, it's like I want to know what amount of current, direct current, will give me the same heat which AC is giving me over one complete cycle. यानी कि एक complete cycle में, ये जो आपकी complete एक cycle है t time period की, इसमें आपका जो I वेरी करता रहता है. कौन सा I? Alternating current. This alternating current is continuously changing. इस alternating current की कौन सी ऐसी वैल्यू हो जो मुझे उतना ही हीट जनरेट करके दे जितना मुझे एक डीसी करंट, डीसी सर्किट दे रहा है. फॉर एग्जांपल, इफ़ यू रिलेट देम, यू विल फाइंड दैट दिस आई नॉट स्क्वायर बाय 2 is basically that current, and if I have to find this value I bar, it would come out to be I naught upon root 2. This current is basically called as the RMS current, IRMS. So you will say that IRMS is that constant current applied across a resistor which gives me the same value of heat across one complete cycle which an AC source of I max I naught is giving in the same cycle. Same time period में I naught upon root 2, that is you can say that it would be around 0.63 times I naught. I naught का इतनी % जो वैल्यू है वो इतना ही हीट जनरेट करेगी, ये कांस्टेंट वैल्यू, जितना ये पूरी AC साइकिल, जितना ये पूरा AC एक कंप्लीट साइकिल में मुझे हीट दे रहा है. सो दिस इज़ द वैल्यू, दिस इज़ द इम्पोर्टेंस ऑफ IRMS. The same way you can also get the value of VRMS, that is RMS value of voltage. It would be V naught upon root 2. This is the peak voltage and this overall thing is VRMS. This is the significance of AC, this is the significance of RMS value for any AC source, because with AC sources, average over one complete cycle of the current flow comes out to be 0. So what is the, how can we interpret things based on that? अगर current ही एक पूरी complete cycle पे 0 आ रहा है तो उसकी significances, उसके uses कैसे निकलेंगे? तो इसलिए हम RMS value calculate करते हैं, because that enables me to relate my alternating current with the DC, with the effects of DC. बिकॉज DC का इफेक्ट है हीट जनरेट करना. सिमिलरली AC का इफेक्ट भी होना चाहिए हीट जनरेट करना, पर AC की एक कंप्लीट साइकिल में DC की कितनी वैल्यू उतनी ही हीट जनरेट कर सकती है. सो दैट इज़ माई IRMS. This is the amount of constant current which we need to apply across a resistor to give me the same value of heat generated across one complete cycle, which the AC source of I max, which the AC source of maximum value I naught is giving. AC is continuously changing its value, right? So this is the case. So with that, we'll end this topic of VRMS and IRMS, and we'll move further on the application of AC sources on resistor, inductor and capacitor in the next video. Thank you.